So what I'm going to be telling you guys today is a personal story. I'm going to be telling you my story, where I started out. I'm going to be explaining my vested interest in Africa as an African, as somebody who was born here. And I'm going to be telling this from the vantage point of someone who has been extremely blessed to have trained at some of the best places in the world, with some of the best minds in the world, and now having unique sets of skills in computer science, in math, in medicine, how I see that there's application for this through artificial intelligence. Just a quick show of hands. How many people are artificial intelligence programmers or practitioners and are actually doing that? Great. So I'll say probably about a third of us in here. How many people are looking to how they could apply this to businesses? More of us in the room. Okay, good. So my talk is catered to you in particular. I figured that most people are not active in the field and have an interest and are looking to get in. Wonderful. So from healthcare, healthcare is a big issue, right? Healthcare is a central part of who we are and of how we can live good and meaningful lives. However, in Africa, we have a big problem, all right? In all of the world, we have a big problem. We have a problem of access to healthcare, in particular, access to specialized healthcare. This graph that you see up there, this schematic, was put out by the World Health Organization in 2016, okay? And what it shows, it's a projection of what the shortage of healthcare access would be, of healthcare practitioners in the year 2030. It does not tell a very encouraging story, right? As you'll see up there, Africa is in a dark maroon color, right? We're going to have a shortage of over 6 million people. It truly is a tough situation at this point. There are gaps in various parts of our economy. We haven't solved the food problem yet, right? There are technology gaps and the like, but the healthcare gap is by far the biggest gap. There are gaps everywhere in the world, and artificial intelligence at this point in history presents a unique opportunity to do something really, really meaningful and really, really powerful for the continent. Because if people are sick, they can't be productive or live the full lives that they should, all right? Africa is a blessed place. It's a beautiful, beautiful continent, and you don't have to look too far. This is a wonderful sunset. That's a picture that I took with my phone. I took that with my Samsung Galaxy on this trip. Does anyone know where that is? Where? There you go. So it's beautiful, a beautiful place, okay? And you find beauty all across the continent. And it becomes very important for us to uplift ourselves to a point that we can enjoy this, okay? That's Boulders Bay, and I took pictures of penguins. I'd never seen a penguin in my life. But on this very trip to Cape Town, which is my first trip to South Africa, I got these pictures, you know, and they're very inspiring. So we have a beautiful continent that we should be really proud of. That's where? That's the, Cape of Good Hope. That's Diaz Beach. Very beautiful, okay? So we've got something great here, something that's worth fighting for. So whether you're jumping off of Table Mountain or you're celebrating your hike to the bottom of the Cape of Good Hope, I am a very proud African, and I feel a real strong obligation to apply my skills, to apply the opportunities that I've had. I have no intention of shrinking back from the unique skill sets that I've been blessed to acquire, and that's something that I want to convey to you guys today. So this is a picture of my, my high school in Nigeria, in Ilorin. I got a great education there. I made wonderful friends there. These are some of my best friends, you know, forever. And we have a WhatsApp group with over, you know, 150 people, and it's always a buzz. And people tell you what they ate for lunch and so on and so forth. And so those were formative years for me, and those really shaped my outlook in life. At 17, I left for the United States, and I went to the University of Alabama at Birmingham. Beautiful campus. And when I got there, long story short, I decided that very quickly that I was going to become a physician, all right? And in the US, you have to do a first degree before you go to medical school. You'll do a degree, most people will do a degree in biology, because there's a sense that biology prepares you for medical school. Well, in my case, I did mathematics, all right? And after I finished that, I stayed an extra year and did a master's in mathematics, and then I went to Duke Medical School. This is one of the best medical schools in the US. I'm very proud that I went to Duke. I had a wonderful time there. And I had a variety of experiences as a medical student. During medical school, I took 2 years and worked in a lab doing basic science research with somebody that would eventually win the Nobel Prize in chemistry, Bob Lefkowitz. After I left his lab, I went to the computer science department. I actually started programming while I was in his lab. Then I went to the computer science department and did a master's degree in computer science. And then I stayed on at Duke as what you would call an intern in medicine. I think in South Africa, you probably call that a house officer, somebody who's just finished medical school and who does all the work and who gets no sleep. So I did that there. And then from there, I went on to the nation's capital. And I went to Howard University, where I did my ophthalmology residency. And from there to the University of Michigan, the Kellogg Eye Center, where I specialized in the retina. Now the retina is the back of the eye. I'm going to tell you more about that. But what happens in all countries, including the US, including South Africa, is as you get more specialized, there are fewer and fewer people, with that skill set. So there are not enough retina specialists in the world. In the US, there are 3,000 retina specialists, not nearly enough, okay? I was the only retina specialist at the corner of where 3 states intersect, within 40 miles of there in the US during my practice. Illinois, Wisconsin, and Iowa, you draw a circle of a 40-mile radius, and no other retina specialist lived there. So this is happening in the US, a place that you think of as having enormous access to healthcare, okay? We have a big problem there as well, and people are actually going blind in America because there are not enough doctors to treat them. So now come to Africa, come to Nigeria, and you can probably count, or not even count, on one hand how many fellowship-trained retina specialists live in Nigeria, a country of 190 million people. And I assure you in South Africa, you have an enormous shortage of specialists as well. And that's only going to get worse. So we're at an interesting time in history, and it's important to recognize that. And then it's also important to recognize what we can do to fix the problem. So it's one thing that I recognized early in life is that it's not helpful to shrink back from your opportunities, from the things that you've had. It's always very important to look and say, okay, what have I had? What do I have? What have I been blessed with? What have I accomplished? And therefore, what am I obligated to do next? Okay? So I had all these wonderful experiences, trained at all these great places, and along the way, I wasn't just going through school. I wasn't just going through Duke and just going through the University of Alabama at Birmingham. I was excelling. I was at the top of my class throughout the way. And I have a bunch of awards to show for that. So one of the biggest awards I've gotten is the Distinguished Alumni Achievement Award. That's the highest honor you can get at the University of Alabama at Birmingham. And I got that this year. I'm very proud of it. I also, while I was a medical student, I topped my class in neurology as well as in pediatrics. Neurology is important for artificial intelligence, right? Because we're talking about neural networks, and the whole architecture is based off of the human nervous system. It's based off of the visual cortex. So I topped my class in neurology, topped my class in pediatrics. I got the Barrie Hurwitz Award. While I was at Duke, I spent 2 years in a biochemistry lab with my mentor, Bob Lefkowitz. And after I left and went and finished my training, during the course of my training, he wins the Nobel Prize. So I visited Bob earlier this year with my family to go congratulate him. And that's the actual Nobel Prize right there in the background. And I took my whole family with him because my wife wanted our kids to meet Bob, and we had a great time. So I've had wonderful experiences. I've had the opportunity to train with the best of the best of the best, okay? And then this year, my medical school at Duke have, for a couple of years now, expressed an interest in how can medicine be combined with engineering. And they went ahead and actually formalized that process in something they called the MedX. And they did a full feature article on me that because of the course that I've taken in my life and the path and how unique it was. And that was nice. So awards are important. Doing well is important in school. But I think what's actually more important is looking at where you are now. And everybody in this room has enormous amount of access, has enormous amount of power, and has enormous amounts of resources when you look at things on the grand scheme. And so it's very important to look at where you are and say, what does this challenge me to do next? So out of all those awards that I showed you, and I appreciate them as a Christian, a follower of Christ, as an African, as a person who's been given a lot of blessings and opportunity and privilege in the world, I think what's most important for me, I know that what's most important for me is to ask myself, to look in the mirror and ask myself, what am I gonna do with that? You know what I mean? It's not, hey, look at me, I'm so cool. It's, so therefore, what should I do next? And so of all those awards, the one that challenges me the most and the one that humbles me the most, I would say, is that I'm the only ophthalmologist in the world with advanced degrees in math and computer science. And a lot of us, almost everyone in here is a business person. You're entrepreneurs. You know degrees don't mean much in and of themselves, right? It's the skills that matter. I bet there are people in here who maybe didn't even graduate from high school or maybe only did it because you had to. But you're some of the most brilliant people on earth, and you've gone ahead to show that, or will be doing so in the coming years. So I didn't just get degrees, I'm actually a computer programmer, a full stack AI engineer. What does that mean? That means that I could build an Android front-end app, right? I can build an iOS app, and I did that on my own because I'm a company of one at this point who's looking for funding. That means that I am the back-end engineer, right? That means I program in Keras, I program in TensorFlow. That means that I'm the data scientist who's doing the curation of the data, who's cleaning up the data, who's setting up the code and training the algorithms, and I'm the guy who hoists them into the cloud, and I'm monitoring to see what my metrics are. I'm the guy who's printing out those graphs, right? At the same time, I'm the guy who's managing the database, whether it's a SQL database or it's a NoSQL database, and I'm setting up the security rules. Who can access this data? What's your user profile? How do you do authentication? How do you do authorization? And what are the schemes of how you set all of that up? And at this point, I'm the guy who's also trying to figure out, who's on the phone, talking to the insurance company, and talking to the Fortune 500 company who's asking us, what are you guys doing? You're shaking up the market. You just put out the world's first mobile AI app for eye care providers. And we've got $1 billion, and we've got a team of 500 programmers, and we can't do it, right? I'm glad we have wonderful sponsors in the room, but there are a lot of people interested in this problem, from Google to Microsoft to GE to Philips. We're ahead of all of them. And people have asked me, why do you say we? Because it's just you. And the truth of the matter is, it's not just me, because I showed you, where I'm coming from, and I've had so much help along the way, and I'm also projecting where we're going to go, right? If you say I, then when you actually have a team, you keep saying I. So I think of it as this is truly going to be a community effort. So basically, it's important to look at what you're going to do next, and it's important to know what your responsibilities are, and it's important to not fall into the trap of false humility and say, nobody, I am nothing, I have nothing, I'm going to go to the back of the room and cry. You have to look at what you've got and know that you're extremely privileged, and coming from Africa has helped me with that because I know exactly where I came from, and I know what I have, and therefore I know what I have to do next. So I'm an ophthalmologist. What does that mean? An ophthalmologist is a medical doctor, right, who went to medical school and works on the eyes. So I'm a surgeon. I do cataract surgery. I'm board certified. I can do a bunch of things, and that's a general ophthalmologist. In addition to that, I'm a retina specialist. The retina is a very important part of the body. I thought about this quite a bit before I chose the retina. I see the retina as an interface, right, between our nervous system and the outside world. And I see it as a very accessible interface in that sense. We talked about the fourth industrial revolution, which the term was coined at the World Economic Forum by and large. And part of the emphasis is that there's going to be a blurring of the biological, right, with the physical worlds and the computational world. I see the retina as prime real estate in that regard, right? Our entire world is full of an ether, if you will. That's the electromagnetic field, right? It can travel through a vacuum. You have IR pointing the things, and I'm controlling my slides without any wires, right? So there's something going on, and the way that we see is you look at your visual field, you take a signal in, it goes back into your brain. So I chose the retina. The retina is important, and it's how we see. We get data. It's a big sensor, or actually a very small sensor. It takes in your environment, what you're seeing in front of you, that impinges on your retina, that goes to your brain, it computes, and you're able to see. So if there's ever a problem with the retina, that's a big problem, right? Because it affects your perception of the world. Vision is how we learn about our world. It's how we see our world, both literally and figuratively. So as a retina specialist, your job is to know when there's something wrong with the retina and to fix it, okay? A lot of the task has to do with pattern recognition. Pattern recognition. For better or worse, some of my colleagues might get nervous at the thought of this, but it's true. Pattern recognition is highly automatable, right? If you look at something and you say, that looks like that, I label this as that and that as the other, that is something that, by and large, a computer can do. A lot of the buzz about artificial intelligence came from the ILS VLC, the Large-Scale Image Recognition Challenge, which is essentially labels of a bunch of pictures, cats, dogs, houses, trees, flies, bees, trained to be recognized by a computer. And once a year, people get together and compete and say who's doing best, who's doing better. And convolutional neural networks started to win, and then one thing led to another, and industry got interested, and a lot of people got interested, and the whole world got interested and realized that this is possible, this is feasible, this is actually going to happen. So we do a lot of that. And here's a scan that's called an OCT. It allows us to see even more than the human eye can see. So if there's something wrong with the retina, it's a big problem, and that happens. So here is a patient who would have shown up or been minding their own business, and all of a sudden there's a dark blotch in one eye and can't see the middle. This is exudative or wet macular degeneration. The physician would look in the eye and see that there's blood here, and that's a problem. That's a big problem because this is prime real estate, right, as I talked about. And the scan, this laser scan, would reveal that there's fluid underneath the retina. And so that's exudative macular degeneration. This patient has an emergency, needs to be treated with an injection in the eye. And if this patient is not treated with an injection in their eye, if they're in a place where they don't have access, or they think maybe I just need new glasses, I'm going to wait a little bit, this patient's going to go blind. It's a big deal, right? So that's a problem. And it would be great if we can have artificial intelligence that can recognize something like this. And that's what we went ahead and built. So you have this issue where this is normal and this is abnormal, right? And this is a big problem. This patient could go blind. There's fluid under the retina. Bad, should never be there. Other things could happen as well that are problematic. You can have fluid inside the retina. That's called macular edema, and that's a problem. So here we are. This is normal. This is a study that's called a fluorescein angiogram, where we inject a dye into a patient's veins and take pictures of the back of the eye as the dye circulates, and that gives you information about the flow pattern. So what's at the top there is completely normal, and what's at the bottom is not. That patient has a pattern that we call macular edema. It can be caused by a number of things. Diabetes is one. That's a big deal globally, right? A lot of people in South Africa suffering from diabetes. In the US, some people say up to 10% of our population has diabetes. It's a problem in Kenya, in Nigeria, across the continent, and across the world, India, etc. So if we have an automatic way to diagnose and screen this condition. That will be very nice. So in the bottom row, you see that that's not normal. There's fluid inside the retina, and the fluorescein angiogram shows that. This is called a petalloid appearance. That's something that we can train in AI as well to recognize. So what I've shown you is that there are two things that are bad in the retina. Fluid under the retina is not a good thing. Fluid inside the retina is not a good thing either, all right? So if anybody comes up with a way to diagnose both of those things, it would have done a lot of good, and that's exactly what my company has gone ahead and done. So whenever these things are found, often it's an emergency, and the patient needs to be treated. And sometimes, and often, that treatment is via an injection in the eye. You might wonder, what's that like, or what does that mean? And so here's a video of me in my clinic in Dubuque. And this is a patient who has macular degeneration, and whose presentation would have looked like the patient with blood under the retina. So we put on masks in the room, all right? And Mr. Malinga from SquidNet yesterday told you about the work he was doing, that a lot of what we do is actually now happening not inside of operating rooms, but right in the office. This happens right in the office, as you can see. That's the medication that this patient needs. You have to be very precise in the eye. There's not a lot of room for error. It's very small. So you have to put in just the exact amount. So everything is measured. You have to be very precise in ophthalmology. And so what I'm going to do here is I'm going to put an eyelid speculum. So hold the eyelids open. And you can please look away if you don't want to see a needle going in the eye. Feel free, okay? And this is called betadine. This is a way to make sure that bacteria don't get into the eye. And that's a caliper. So everything has to be very precise. You have very little room for real estate. When you're in the eyes, you're dealing in microns or in millimeters at most. The entire diameter of the eye is about 22 to 23 millimeters. And the foveal vascular zone is 500 microns. The cornea is 240 microns. So we just did an injection and take out the eyelid speculum. Sometimes you're in a busy clinic, and partly because of the shortage of specialists, I would sometimes do this procedure 40 times a day. And I'm making treatment decisions all along the way. And we're trained to do that, and we do that safely, and we do that well. But I'm sometimes literally running between rooms, making a decision, doing a procedure. This is a full surgical procedure. Can you imagine doing 40 of this in one day, running between rooms? And that's in the US, so, and sometimes you might need to do about 50 of these. So there's not enough doctors to go around. The population is growing. There's no chance for us as human beings to catch up to this problem. I'm talking about the shortage in the US. I could stay in the US forever and be doing my AI there. But the truth is, there's a much bigger problem in other parts of the world. So I told you, just to reiterate, that fluid inside of the retina is bad, fluid under the retina is bad, and a number of conditions have those things. Diabetes is one, right? Wet macular degeneration is another. I just showed you a picture of that. Also, after people have had cataract surgery, they can get swelling in the back of the eye that can look very much like diabetic retinopathy. That's a bad thing as well. And then vein occlusions, either from diabetes as a risk factor, either from high blood pressure or from blood clots. People can get blocked veins that can cause this type of swelling. Some people would have inflammation from autoimmune diseases like lupus. They can get swelling in the back of their retina as well, macular edema. Then central serous retinopathy is a poorly understood condition that's associated with steroid use, stress levels, type A personality, mostly happening in males. would have fluid under the retina as well. And then detachments. We've all heard of a retinal detachment, right? If the macular comes off, you'll have fluid under the retina. So any one of these conditions, if a person has any one of these things, it's serious, right? They're at risk of going blind, and I guarantee you that most people, probably at least half the people in the world, will have no kind of access, no chance right now of any kind of access to see somebody that knows what's going on when they get this. So it's absolutely necessary that we get AI and technology out to the people. And that's what my company has gone ahead and done. So I started a company, RETINA-AI, February 2017, and we have shaken up the world of AI and eye care. And I can say there's probably not enough, there's probably not an ophthalmologist that hasn't heard of us in the world in that short time. So that's good. So we've gone ahead and put out the world's first mobile AI device for eye care providers. And what it does is exactly this. It detects macular edema and subretinal fluid. And so I'm going to do a live demo for you guys here. So basically what the app is you know, it's on a mobile device, a mobile app, and the user, be it an ophthalmologist, a general practitioner, a nurse, or even a technician, depending on the country, depending on the need, right? We're going to be practical, and our objective here is to improve lives. We'll take the phone on the app, point it at a picture of the retina, the OCT picture, that scan that I showed you. Take a picture of it. Immediately, that goes into the cloud, computes on a machine learning algorithm that we built, comes right back, and gives an answer as to whether there's a problem or not. It gives a binary answer. It says there's either subretinal fluid or macular edema or not. And if there's either of those things, as I showed you, that patient's in trouble, they need to seek help. So we can now just very easily plug that into a telemedicine system or some other form of triage and have the patient be seen. So let's see a demo of this. So here's the app. And in this case, I'm demonstrating it to you on my computer. So what I'm going to do is upload a picture as opposed to taking a picture, because it's not physically in my hand in this demo. So you saw there was an option back there of camera. You hit camera, you take a picture, it immediately goes in the cloud. And once you do that, you'll see something like this. Our latency, so AI is computing the diagnosis. Our latency is currently anywhere from about 10 seconds to about a minute. And so I'll see if it takes any longer than this, we'll carry on, and our answer will be back shortly. 1, 2, 3, 4. Okay, good. So we're going to come back and look and see how we're doing. It might take up to a minute at this point. Okay. So that's pretty amazing. That picture I just loaded up is physically gone into our servers, into the cloud, and is going to do inference and is going to give us an answer in a couple of seconds. I'm going to check once more before I continue and see if we're, yep, good, then that's it. And the answer has returned. It says AI is 99% sure of this diagnosis, and it is wet, because right here you see fluid underneath the retina. At this point, the user can click and get more information on what that might be in terms of what the differential diagnosis is, or they can opt to take another picture or load another image on it. So that happened real time, right? That's pretty exciting. So that's AI at work. That's not us talking about doing AI. We've done this, we've built this. This is actually already on the market and has been downloaded in multiple continents already and is already being used. And so that's our first product. And by this time next year, I think it'll be mind-blowing what we would have done. AI is moving very fast, okay? So we're very excited about that, and we're very proud of that. Great. So everything worked out, and this is basically people sign in, log in, the physician, or the user, I'm saying the user, the eye care provider, depending on the country. There's some countries with one ophthalmologist that I know of a country that has, we're not talking about retina specialists, we're talking about ophthalmologists. So it's amazing what the need is in a lot of places. And in medicine, whenever you put out a new device, a new drug, you have to test that scientifically, rigorously, and validate that. And so we've done that and are doing that, and we'll continue to do that. We're doing currently a multi-center trial called the Dayton Study. And what that stands for is Diagnostic Mobile Artificial Intelligence for detecting, technology for detecting fluid underneath or inside of the macula. And what it is we have several board-certified ophthalmologists, such as myself, who are also retina fellowship trained, such as myself, using the app. And so they take the app, they look at a picture, they say what it is there fluid or not, and then they take a picture of that picture that goes in the cloud, gives them an answer, they record the answer and compare, and that's how we're validating to see how our algorithm is doing, and we're doing pretty well. So this is we haven't even hit the data science part with our biggest hammers yet, but we're already very proud of what's going on. Our Dayton Study group is spread out across the globe, mostly in the United States. And we have 3 centers have submitted their results at this point. We have over 12 centers altogether. And our sensitivity is 86.5%. I'm very confident we're going to be able to drive this north of 95% with just a little bit more effort on the data science end of things. But that already is greater than what the FDA has approved for one of our colleagues / competitors who got the first FDA-approved medical device, period, for detecting diabetic retinopathy. They had about 86% as well. But we're going to be able to get this to 95%. I'm very confident of that with just a little more effort. As soon as we get more support, we'll be able to. We're currently deciding where to spend our time. So how are AI systems built? I put this in here with the expectation that not everybody in the room is actually programming, TensorFlow and so on and so forth and building systems, and that was the right thing to do. So you guys at this point have seen, have been through a number of talks from yesterday where you've gotten the general drift that it's all about data, right? The data gets labeled, and then you do some processing on it through the algorithm, and the algorithm somehow then is able to learn and know what's what. That's the whole idea of the intelligence part of the business intelligence. And so in this case, we have retinal images, right? And these retinal images are labeled by someone who knows what those labels are. That's the expert, somebody who's a retina specialist. And then we put that through the algorithm, and basically what you see on the schematic is that it goes in through the algorithm, and the algorithm is going to guess randomly at first. And if it guesses right, everything goes fine. It says, I did well there. But if it guesses wrong, it gets dinged a penalty, and it's wired up. This is called optimization. It's wired up such that it tries not to do that again. It doesn't want to get these penalties. So that's how the thing is programmed. And so the more you run it through this, the more it's going to learn how to get the right ones correct. It makes good sense, right? And so schematically, that looks something like this. A convolutional neural network is called convolution because of a certain operation it's done. That's this layer, is the convolution operation. And then next you run it through a neural network, and this is modeled. We as human beings got this idea from biology, from knowing how the human brain is wired. Because in the 1950s, experiments were done on cats. I was just telling Sox about that. And we learned that one neuron connects to the other. There's a hierarchical scheme here, and that it passes that information along. And that's exactly what we just built up. And Kunihiko Fukushima in the 1970s tried that, and it worked, really. But there was no AI because there wasn't the computational power, people say, of GPUs. That's not quite true. Sometimes things are just hidden in plain sight. That's more of the truth, because we can do good AI without GPU. It was right there. AI has been there the whole time. Isn't that something? What else is there that we're not seeing? So yeah, you do this over and over, and then you now have a trained algorithm, which you put up in the cloud. And we, thanks to our sponsors, the cloud. There are really 3 large vendors in reality. Overall, there are probably over 100 companies who have some kind of cloud service or the other. The three big names you know are, that the biggest players are Google, Amazon Web Service, and Azure, Microsoft. So you host that on some cloud service provider, and here's the mobile device in our system, Fluid Intelligence. When the user takes that picture, it goes into the cloud. The demonstration I just did, that picture went through the World Wide Web and into our cloud server in Northern California, or maybe it's in Iowa, and then ran that and sent back an answer that came back, and we saw the results that this is wet, this patient's in trouble, get them some help. That's the architecture. Okay, so back to the problem that I put up in the beginning. Big problem, big problem. People are going blind, people are dying young, kids are without mom and dad, and so on. Our productivity is way down compared to what it could be if we had a better healthcare system. And this is a projection, so it's about to get worse. It doesn't look this bad today, but I'll tell you, this is pretty bad. As a retina specialist, I've had opportunity to visit a couple of countries, and I can tell you that the gap is as far as from here to Mars. And that's not necessary. Today, AI presents a tremendous opportunity to close that gap and to actually lead, right? Because everything I did, I could have done from Cape Town, perhaps. You know, there's nothing that I used that was unique to my location in building this app, which is very interesting. Okay, other than the confluence of skills that I have, which could go anywhere, and that's important. That's where education becomes important. And I'm glad, Nick, about your efforts to have people in here in the conference who are being trained on AI skills. That's the hardest thing, is having people that know how to use these things. But that problem is actually also going to decrease because a lot of people are now looking to make AI more accessible to everybody. Not everybody's going to need to be a computer programmer. So, big problem, big opportunity, all right? There's the very meaningful part of improving people's lives. This is something that you, your grandkids, would be proud of forever, right? It's very good to try to solve this problem. It's also a great business opportunity to try to solve this problem. There's 7 billion people on Earth. And that's the space that we're interested in. Africa is in a very unique position at this time in history because certain things, certain ingredients are set up, you know, for success. Certain waves, I really enjoyed Dr. Odaibo's talk yesterday. Certain waves have already occurred, like the mobility wave. Dr. Odaibo mentioned in his talk that Kenya has 90% mobility penetration. 90% of youth in Kenya have mobile phones, and 60% of people overall. So certainly, every hospital, every nurse, every doctor on the continent has a mobile phone, or in some cases, multiple mobile phones. So that is going to be a key part of solving the healthcare problem in Africa. Mobile, it's big, all right? What other factors are lined up for us is the fact that we're connected continent. When I left the shores of Nigeria at the age of 17 to go study in the US, this was not the case. The picture wouldn't have looked like this. But now we have all sorts of connectivity, satellites, right? We have, I mean, the World Wide Web itself is really just spaghetti ducked together with, you know, duct tape, glue, bubble gum, whatever you can find. And we've been able to do that also, and everyone else in the world has been able to connect this up very nicely. So we can reach people where they are with this capacity, this very precious commodity, which is diagnosis, the ability to diagnose what's wrong, what's going on, and inform what needs to happen next. So that's very important. And then the third factor that is looking really good for Africa is just open source. You know, the ubiquity of opportunity to do things like machine learning, right? A lot of this stuff is free, just all of it. I mean, if it's good, it's free almost. You know, these days. And machine learning, data science, tremendous opportunities are out there for these things. There are plenty of options for developing skills. You go on the Stack Overflow. If there's a bug, if there's a problem, there's a small community of people who've had that problem before, and people have answered them, and specific answers. When I do my this and that for loop here, there, the other, I'm getting this type of an error when I try to hoist my algorithm into the cloud, or when I try to do a certain type of loss function or customize it to whatever your problem is. There's probably someone that's had it. And even if no one has, there's still people who would find that interesting to try to solve and figure out for you what's going on. This is free stuff. And people have put up tons and tons of YouTube videos. We had a great opportunity to go to Stellenbosch University yesterday for the Indaba simultaneous conference, and so much energy, so many people. And so Africa has a moment, you can sense the energy in the air, it's palpable, that there's something going on, and we're really looking to raise the human capital, and it's waiting to be raised up to solve some of the world's most challenging problems, okay? And so my company is very nicely positioned at this point to take advantage of some of these things. And the idea, again, is distributed diagnostic capabilities through the cloud. It sounds cool, right? It's real, it's happening, we've done it. I just demonstrated it to you, distributed diagnostic capability through the cloud. Okay? And it presents a great business opportunity. I recognize this is a business conference, and entrepreneurship is vital because it sets a standard. It makes you put out a finished product, right? And it also affords you the resources to keep going, to get to where you want to go. So with this, at this time in history, Africa can become an exporter of the latest cutting edge technology, and that will be a very nice thing, all right? So we're very excited. RETINA-AI is primed and ready to go, and I put this up here, that's a QRS wave for heart, in that what I just showed you and the technology that's behind this generalizes to really any type of diagnostic healthcare problem or concern. And we're looking to spread out into those areas as well, and we're very primed and ready to do that. So if there's anyone who's looking to get involved with this, if there's anyone who wants to invest in a company that's going to make a heck of an impact, certainly look us up, and let's talk about that, okay? I want to acknowledge the Dayton Study investigators. I have a group of dedicated ophthalmology retina specialists who've signed on with great excitement and enthusiasm to testing out our apps. I would love to thank my wife, Lisa. She was right that this was going to be too long a flight from Houston. I live in Houston, Texas. That's where we live, to Cape Town with our kids. Danielle, who's 3, and Joy just turned 1. And so they've been the team. That we that I talk about, that's it. And I want to thank God for just the phenomenal opportunities that I've had, and for also the direction to pick the right problems to challenge myself with next. This is my contact information. That's my email. Please take that down. My email, this is our website here. That's my LinkedIn. If you have any interest in this, if you are an investor, we're currently raising capital, okay? Our company is going to be huge, huge. We've gotten phone calls from people that have said, you're shaking the trees, what are you doing? Because it's an exciting time, all right? So let's talk. Thank you very much. And that's my family. That's our Christmas card we sent out last year. Questions? That's a great question. Currently, what we're thinking is this is a way to, first of all, notify people, the system, both the patient and some care provider, that there's a problem. And the least disruptive system at this point is a referral type of a system in which once we know that this patient has wet macular degeneration, is in acute trouble, we inform both the patient as well as the nearest provider that they need to meet up and this patient needs to be treated. That does not, and now the issue of whether lower level providers or what we call allied health providers people with less training can begin to do things. That's very controversial within our field at this time, but the NHS in England has started to train nurses, and nurses are doing these shots. That's the only place in the world that I know of, but I'm sure this is happening everywhere. Not in the US, okay? Not in a lot of other Western countries. In the US, it's really even frowned on for general ophthalmologists to do these injections by some of my colleagues. But it's happening, of course, because otherwise people will be blind. So there's no doubt there. So a lot of general ophthalmologists, even in Dubuque, the city where I lived, that was at the intersection of 3 states where I was the only retina specialist living there within 40 miles. A number of general ophthalmologists do these injections. I was completely fine with it because I think practically it's not about us, it's about, what good can we do in the world? And if somebody's going to go blind, there's no argument to be had about, who can do these things. So that's going to become an issue. And I think what artificial intelligence is probably going to do is it's probably going to it's going to allow for people with less training to more responsibly do more than they're doing today. And what's going to drive that is the fact that there's just a need for it, and we just don't have people with the training. So that's probably going to happen.
Sorry, next, any other questions?
Yeah, back there.
Doctor, thank you so much for such an insightful presentation. My question is with regards to legislation. So in the tech space, I think a lot of us are seeing at the moment that there's room to make rapid progress across a number of different impact areas, but specifically in highly regulated industries like financial services, and I would imagine specifically in the medical industry, sometimes legislation can be more of a hindrance than a help because it doesn't keep up as quickly as technology is enabling us to help people. Are you seeing that as a problem, both from a global perspective and also from an African perspective? And then the second part of my question is, with regards to that, who do you think is leading the pack in terms of being able to keep up with technology in the regulatory space?
Great question. You guys are asking wonderful questions. These are things I think about. So it's very country specific in terms of where regulation is important. We know that this is a big deal, right? We're changing the way we live, and we're reshaping the healthcare landscape, and everybody has to be involved in that. Certain countries tend to be very pro-innovation. And I'm very fortunate, I'm also an American. I emphasized a lot during this talk, my Africanness. I'm a US citizen, as well as a Nigerian citizen. The US is very pro-innovation, and that's why you see a lot of leadership there, and there's also a lot of funding for this type of work. The FDA was really, I think, really on the side of this. And there's a device that's been approved already, and I see it. They're in the right place. They're not taking an obstructionist stance towards advancement. I think the FDA understands the problem, and also I'll use the example of in Kenya too. I think that things are looking good there. Kenya has led the world in mobile money and innovated in that space. From Dr. Bitenge Demo's presentation, and he's a part of the government there, and they didn't obstruct it. They allowed this to happen, and it's a good thing. It made life better. So Africa is interesting because there are so many countries in Africa. 54 this week. Who's Oh, got it. So 54 countries. So it's a more heterogeneous landscape where regulatory issues and the like might be more difficult to man. But at the same time, Africa is just, on average, unregulated space, in that sense. And so it's also, as you mentioned earlier, prime for adoption of new technology.
One more question, and then we've got a, yeah.
I just wanted to check, so the AI obviously detects whether there's a pathology present or not present,
Mm-hmm.
but when the image, is it possible for the image to get sent or returned back to the ophthalmologist that actually highlights where it actually detected all the DR, like how it actually came up with the conclusion that there was something present or not?
Mm-hmm. Yeah, that's a solved problem, object detection. It's nice. But again, one thing with development and implementation of AI, it's great to be on both sides, right? So I think with AI, it'll be very important for people to focus on a domain, understand the domain, know what the problems are in a deep way. And that's going to require lots of interdisciplinary teams. Now, to answer the question, I'm a retina specialist, right? So you saw me doing the injection, I make the treatments, I'm the expert on that side. And so I know that that's currently not an important thing to know how to do, but it's solved. Object detection is it's an easy problem, and we could have it do that, and that could be for other problems in the eye, but in terms of the retina and treatment decisions, that plays zero role at this time, right, in treatment. You do a shot in the eye if there's a reason to treat, and you don't need to know exactly where the edema is or what the exact shape. However, yeah, that's the answer to your question. However, in future, AI could allow us to further stratify different types of conditions, different type of pathology, if we, say, become more precise and learn that if you have this type of a shape to the vacuoles of fluid or subretinal fluid, then maybe drug A works better than drug B. If there was any way that would change management or outcome, then that becomes important, in which case we would immediately, but at this time, it has no role in our treatment decision. Good question. Thank you.